Hello everyone, welcome back to the channel. I am Nikhil Kumar. In our last video, we have learned about the node selector. But in today's video, let's go beyond it and dive into node affinity. It allows more expressive rules for controlling where your pods get scheduled. We will go through a real hands-on demo and break down the YAML in detail. So let's get into it. Let's say if you have two nodes with a two different label, node 1 with a zone label and the node 2 with the environment label. And if you want a pod to run on a node in the zone US-West region if possible, but not mandatory. Or maybe your workloads should only runs on the node with the labels environment equal to prod. That's where node affinity gives you more control than plain node selectors. Now let's see it in the action. Let's jump onto the terminal. So this is our Kubernetes cluster, kubectl get node. This is a two node. So first of all, we will label one of our node, that is the agent one. In our last video, we have also labeled the agent one with the different label, that is disk type equal to SST. But this time I'm going to label it with a different key value pair. So kubectl label nodes rk2 hyphen agent one and label is zone equal to US hyphen west. So this label is what the scheduler will use to match against. Now let's try to create a pod with the required affinity. So let me create one manifest file, pod-node affinity.yml. Let me update the manifest file. Let me break this down for you line by line. So you guys are already aware about the API version, kind and the metadata as well as the specification. But in this particular manifest file, you will feel this particular difference. We have a lots of configuration changes regarding to the affinity. Don't worry, I will explain this in very much detail. As you can see, at first below the specification, we have an affinity keyword. This is the top level field under the spec to define any kind of affinity, whether it is node, pod, etc. Here we are using the node affinity. So basically we are specifying the rules related to the node selection. So for that we are using the node affinity. Then we have a hard constraint here. So required during scheduling, ignored during execution is a hard constraint. If the condition is not met at the time of scheduling, the pod won't be scheduled at all. However, it won't be evicted later even if the pod label is removed. Then we have a node selected terms. Think of this like a list of OR condition. If any of the terms match, the pod gets scheduled. Then we have a match expression. This is where you define the actual condition. Then we have a key, operator and the values. So basically this says the pod only gets scheduled on the node where the label zone equal to US-West exists. So let's apply this manifest file. Save and exit. kubectl apply -f pod-node affinity. The pod got created. Let's see on which particular node it got created. And we can see it got scheduled on the rk2 agent 1 node. So that is the correct node because we have set up a label that is zone equal to US West 1 and it already exists on our rk2 agent 1, so it got scheduled over there. If we don't have any label on this, so it will be in the pending state. Now in the node affinity, we have a soft version of it. So for that, let me create a manifest file that is pod-preferred-affinity.yml. So let me update the manifest file and let me explain this thing to you. So most of the thing remains same as the hard constraint. But here we are using the soft version of it, that is preferred during scheduling, ignored during execution. So if a node with the zone equal to US-West is available, the scheduler prefers it. If not, it can still schedule the pod on any other node. Basically, we are giving a preference to schedule a pod on the node which is having a US-West label. If it is not there, then it can be scheduled on any of the node. And here you can see we are specifying the weight. So we can also set multiple preferences with different weights if needed. So let's apply this. kubectl apply -f pod-preferred and the pod got created. Let's verify the same with the -o wide and we can see it also got scheduled on the rk2 agent 1 node. Why? Because it's having the label. But if we remove this particular label, it still got scheduled on the any other node. So let's try with this particular approach. So let me copy this particular file, duplicate pod.yml, and let me update this particular thing with the US West 2. And if I apply this, duplicate.yml. Oh, I have already having a pod with the same name, so let me change the name as well. So preferred 2, and let me apply this now. The pod got created. Let's verify this -o wide. As you can see, it got scheduled on the agent 1 only, because it preferred to run on the agent 1. However, we don't have any label on it. As we can see, kubectl describe node rk2 agent 1, and we don't have any label, that is zone equal to US West 2. And if we jump onto this, we don't have any, but still it got scheduled as per the scheduler or the node filtration. So let's quickly recap what we have learned today. So we have two types of affinity. First is required during scheduling, ignored during execution. This is our hard constraint. And other is our soft preference. Just now we saw this. That is preferred during scheduling, ignored during execution. I will show you the hard constraint in a different example as well. Let's copy this particular file to hard pod.yml, and let me update the name of the pod with hard, and label is 2, and this one is 3. So let me apply this -f hard pod.yml. The pod got created. Let's see this. As you can see, the pod is in the pending state. Why? Because we have a hard constraint that is required during scheduling. If that particular label does not match, the pod will remain in the pending state. If we run the same command again, we can see it's still in the pending state. So that's the node affinity. It's a powerful way to schedule smarter in the Kubernetes. In my upcoming video, we will compare nodeSelector, node affinity, and tense and toleration, and explain when to use which. Make sure to subscribe so you don't miss it out. Thanks for watching. See you in the next video.